Okay, let's deal with a little bit of probability now. Probability is the number of favorable results over the total possible results. And probability is always going to range between 0 and 1. 0 means it's definitely not going to happen. A probability of 1 means it's definitely going to happen. But most of the time, our probabilities are going to fall somewhere in between the two. You can write probability as a fraction, a decimal, or as a percent, but you have to make sure it's between 0 and 1. So if we roll a 6-sided die once, what is the probability of rolling an even number? Well, if we have a 6-sided die, that means the total possible results are 6, because you can get a 1, a 2, a 3, a 4, a 5, or a 6. Well, even numbers would be 2, 4, and 6. So those would be the favorable results. So we could have 3 possible good things over 6 total results, which means our probability is 1/2. Now, a lot of times you'll have to find probabilities for several things happening at once. That's what is called a compound event. It's a combination of 2 or more simple events, and it can be found by multiplying the 2 probabilities together. Now, 2 things can happen. You can have independent events, which is events where one outcome does not affect the other outcome. On the other hand, dependent events means the result of the first outcome affects the probability of the second outcome. Okay, so we have both cases demonstrated here. If you roll a 6-sided die and flip a coin, what is the probability of rolling a number bigger than 4 and having the coin land on heads? Now, if we're rolling a 6-sided die and flipping a coin, those 2 things are totally separate. Okay, flipping a coin is not going to affect rolling a die, and rolling a die is not going to affect flipping a coin. So these are independent events. So we can just figure out each of the probabilities and then multiply them together to get our answer. So for the die, we want a number bigger than 4. Once again, for our die, we have 6 total possible results. And if we want a number bigger than 4, our options would be 5 or 6, which means there's 2 favorable results. For our coin, if we want it to land on heads, well, there's only 2 possible options, heads or tails, and heads would only be 1 favorable outcome. So we have 2 6 times 1/2. We're going to multiply those together. We can either simplify now or simplify later, but let's multiply and we get 2 over 12, and then we can simplify that to 1 over 6. And that is the probability of rolling a number bigger than 4 and having the coin land on heads. Okay, well, that was an independent event. Let's look at some dependent events. There are 4 yellow marbles and 6 blue marbles in a bag. What is the probability of choosing 2 blue marbles without replacement? When you see without replacement, that usually clues you in to the fact that it's dependent and you need to be careful. Because if you take out that first blue marble, okay, there's not going to be the same number of marbles in that bag. So the probability of taking that second marble is going to be affected by taking out the first marble. Okay, so we're going to say, let's assume that we reach our hand into this bag and pull out a blue marble. Okay, well, that probability, 4 plus 6, there are 10 total marbles at first, and there's 6 blue ones. Okay, so our first probability of grabbing a blue marble is 6 over 10. So now we need to assume that we have taken that marble out. We have a blue marble, okay, which means that the number of marbles in our bag has gone down from 10 to 9. And if we took out a blue marble, we don't have 6 anymore, we have 5 instead. Okay, so let's cross reduce in this case. We'll simplify before we multiply. 5 goes into 5 once, 5 goes into 10 twice. 3 goes into 6 twice, and 3 goes into 9 3 times. And actually I can simplify here more. They reduce. So really it's just 1 times 1 is 1, and 1 times 3 is 3. And that is our dependent probability.